Some people like polynomial long division. More people like synthetic division as a way to divide polynomials. But there is one advantage to polynomial long division, this method, compared to synthetic division. And that's when you have something in the denominator which is not an easy x plus 2 or x minus 4 or something like that. 3x plus 5, that 3 that's in front of the x just causes things to get a little more complicated with synthetic division. Not saying you can't do it, but at this point some people really prefer to use long division as a method because with long division, it's always the same. Nothing really changes with the technique that we use, but with synthetic division, sometimes there's some more tricks that we have to use. So going into how we solve this particular problem, this will be similar to something that we've done before. It's just that now we have a 3x instead of a regular x. So what we have to do here is first, I'm going to divide this negative 9x cubed by 3x. Okay, and what do we get? We get negative 3x squared. So that goes up top here. And now what we do is we multiply this back down against that divisor. So we get negative 9x cubed. That part shouldn't be surprising. And then we get negative 15x squared right here. So now if you notice, I have a subtraction sign over this whole parentheses. We're going to subtract these terms in blue from what's above them. So negative 9x cubed minus 9x cubed, those cancel out. Negative 9x squared minus, notice this, it's minus 15x squared. So that's going to be comma plus 15x squared. So negative 9x squared plus 15x squared gives you 6x squared. And then we just bring these guys down. So we get 25x and 26. Now we're going to divide this new bottom row by 3x plus 5. So dividing 6x squared by 3x, you get 2x. Now you multiply this 2x times that divisor, and we get 6x squared plus 10x. Okay, so now we're going to subtract the new bottom row from the one above it. You get 0, 15x, and now we bring 26 down right here. Okay, so the process continues. 15x divided by 3x is just 5. 5 times 3x is 15x. 5 times 5 is 25. We subtract these down, and look what we get. We get 1. This right here is the remainder. So you can just plug that in right here for the remainder, right up here for the remainder over there. And in this case, it's just a number, but it's possible with other problems you might get like x plus 1 or x squared minus 3 or something weird. Whatever is left at the end and you can't divide anymore, that's your remainder. And we'll see different examples going forward. Now the quotient is this entire top line right here. That's what goes into the quotient section. So we have negative 3x squared plus 2x plus 5 with a remainder of 1. And the big money question at the end, is 3x plus 5 a factor? Well, that's false. The reason it's not a factor is because there is a remainder that is not 0. If the remainder were 0, then this would be a factor. But it is not a remainder of 0. So by the factor theorem, by the remainder theorem, this is not a factor.